Hello everybody, getting ready to do lesson 1.6 part 2 classwork today for Algebra 1 Math, and on your classwork sheet you got 24 points. Students have that out in front of you now. You got 9 points to go into your notebook or your notebook guide. Use precision and measurement part 2. Students, don't forget, put your name and date period here on your tablet, your PC, your iPad, your iPhone, your Droid, your Chromebook. So let's go into page 1 here. Significant digits to the nearest centimeter. Down here we got 1, 2, and then 3 centimeters. To the nearest centimeter, the diameter of a United States quarter is 2 centimeters. Just ballpark there. Measured to the nearest millimeter, the diameter of the quarter is 24 millimeters, which is way more precise. The measurement of 24 millimeters is more precise because it is given using a smaller unit of length. So when you have a smaller unit of length, it's more precise. In the two coin measurements, notice that the numerical value 24 has more digits than the value 2. You can use the number of significant digits to describe the precision of a measurement. Significant digits are the digits in a measurement that carry meaning, contributing to the precision. So let's go into a table here of this key concept, determining significant digits. There's a rule, there's an example, there's significant digits, and then number of significant digits. So all non-zero digits, an example here would be 281.39. And then we go significant digits will be 281.39, and because we go all the way out here to the hundreds here, plus we have a 3-digit number out in front of the decimal, and then the number of significant digits in this number would be 5. So zeros that are to the right, here this is a rule, zeros that are to the right of both the last non-zero digit and the decimal point. So for example, we got 0.0070, so the significant digits would be the one that goes beyond the 0 that's beyond the 7 to show us how precise of a measurement we've attempted here. So the number of significant digits here would be 70 will be out here. We know we can see what's going on here, but the 7 and the 0 are what's really important. So zeros between significant digits. So we have 500.7. So we have 500.7. We got 4 here. We got 500, and we got a little bit more than 500. We got 0.7. So we have, in this case, we have 4 significant digits. So going into page 4 here, zeros at the end of a whole number are usually assumed to be non-significant. For example, 220 centimeters has 2 significant digits, while 202 centimeters has 3 significant digits. So students, now define significant digits in your notebook here, page 5 of your of our classwork today. Page 5, so significant digits, define that. And let's go into our next example here. Identify significant digits. Determine the number of significant digits in each measurement. So part A here, we have 290.01 grams. So the digits 2 and 9 and 1 over here are significant digits. So they're non-zero digits, so they are significant digits. They're non-zeros. The zeros are between a significance, the 0 here, 0 there. So they are also significant digits. There are 5 significant digits in 290.01. And then part B here, 0.8500 kilometers. There are 4 significant digits in this number here, 0.8500. B, the digits 8 and 5 are non-zero, so they are significant digits. The 2 zeros to the right of the last non-zero digit are also to the right of the decimal point, so they are significant digits as well. This tells you how accurate of the measurement it is. If it kept going out here 0, 0, 0, 0, even though that might be a little redundant, it tells you how precise the measurement is, so that therefore they are significant because of that. And then we have 4,000 miles, and the digit 4 is a non-zero digit, so it is a significant digit. The zeros at the end of a whole number are not significant, so there are only one significant digit in the number 4,000. Let's go into a guided practice here. Determine the number of significant digits in each measurement. So we have 800.20 feet here, and then this is yours down here, students. Let's do our guided right now. Determine the number of significant digits in this measurement, 800.20 feet. So the digits 8 and 2 are non-zeros, so they are significant. The two zeros between the non-zero digits are significant. These two are significant. The 0 to the right of the last non-zero digit is also to the right of the decimal point, so it is a significant digit because of that. There are 5 significant digits in the number 800.20. There they are, the two zeros between the two non-zero digits, and there's your 0 to the last. That's significant because it is to the right of the decimal point. So there are 5 significant digits in this number here. So significant digits in calculations, when you perform calculations involving measurements, the number of significant digits that you write in your result depends on the number of significant digits in the given measurement. So, wow, the number of significant digits in the result depends on the number of significant digits in the given measurement. Given to work with also determines how many there are, determining significant digits in calculations. So, operations, rule, and then example. So say addition and subtraction. The rule is round the sum or difference to the same place as the last significant digit of the least precise measurement. So we have 3.24. This is 3 and 24 100. So plus 7.3 will be tenths. So we have a measurement here is tenths and one that's hundredths. So 10.54, so 10.5 would be tenths. That would be your significant digits here. Because of 7.3, that kind of destroys any kind of going to the hundredths of a number so far as like precision. So our precision here is kind of limited by the tenths, so we just round it to 10.5. And then multiplication and division, the product or quotient must have the same number of significant digits as the least precise. Least precise is the term here. Least precise up here as well. So 40, we got one significant digit, times 31, we have 2 significant digits. So the answer would be 1240. That would be your exact answer. So we just narrow it back to 1000. Because our least precise up here would be the 40, and then the 31, we're going to throw out the 31. We just multiply basically 40 times 25, and we get 1000 as our one significant digit. It would be 1000. Let's go into an example here. And we have example 3, calculating with significant digits. Perform the indicated operation. Write the answer with the correct number of significant digits. So we have 45.1 centimeters plus 19.45 centimeters. So we have 45.1 centimeters plus 19.45 centimeters equals 64.55 centimeters. The least precise instrument here is 45.1. Its last significant digit is in the 10th place round the sum to the nearest tenth. So to do that, the correct sum would be 64.6. We round up here from our 0.55 to 64.6. And then part B, 6.4 feet times 2.15 feet. Here's our least precise, will be the 6.4. So it has two significant digits, round the product to two significant digits, and then when we do that, we come up with the correct product will be 14 square feet up here, to 6.4 to 12, 4 times 0.15. So it'll be rounded to 14 square feet. Let's go into our guided now. Perform the indicated operation. Write the answer where the correct number is significant digits. We have 45.16 square yards divided by 4.25 yards. And then down here, students, this is yours. Let's do our guided up here, 45. So going into our guided here, perform the indicated operation. Write the answer with the correct number of significant digits. We have 45.16 square yards divided by 4.25 yards. So 45.16 square yards divided by 4.25 yards is approximately 10.626 yards. The least precise measurement here is 4.25 yards. It has three significant digits. Round the quotient, we have 10.626. Round the quotient to three significant digits. The correct answer in that case would be 10.6. 10.6 yards is what it would be. That's your lesson for today. Animated PowerPoint math video at AOL.com for questions or course materials. Thank you very much.